Lecture 10. So far we have learned polynomials. But if we use a polynomial to divide by another non-zero polynomial, we get something called a rational expression. So you see this one, the numerator is a polynomial degree 1. The denominator is also a polynomial degree 1. Right? The second one, the numerator is a polynomial degree 1 or linear. The denominator is a polynomial degree 2 or quadratic. This one, the numerator is a polynomial degree 5. The denominator is a polynomial degree 2. So we can divide the two polynomials, but the denominator can never be 0. And we call this rational expression. So rational, you can think as a fraction. Right? If we only talk about numbers, rational means fractions. All right, so we will, because when we have expressions, we want to simplify, or we want to put in a factored form. So this paragraph is saying, similar to fractions, when we need to add or subtract the rational expressions, we need to find the least common denominator, right? So this is the key. We can add them, we can subtract them, but when we do that, we need to form least common denominator, or which is called LCD, least common denominator. Sometimes without talking about it in the fraction situation, we call least common multiple. But let's just recall. So we have those two numbers, right? 1/12 plus 5/18. And we want to find the least common multiple of 12 and 18. And in this case, when we have fractions, we call least common denominator. So 12 is 3 times 4. And 18 is 3 times 6. 4 is 2 times 2. 6 is 2 times 3. So the factors of 12 is 3, 2, 2. The factors of 18, let me use blue color, is 3, 2, 3. So the least common denominator has to include every factor, but only once, right? So if you see 3 is here, is a factor of 12, is a factor of 18, so it's a common factor, we only include it once. Then 2 here, so we include these 2. But then we have the second 2 for 12, so we need to include that. Then we have this 3, we need to include in this. So the least common multiple of 12 and 18 has these 4 factors, which is 3 times 2 times 2 times 3, which is 36. Right? 36 divided by 12, that's 3. 36 divided by 18, that's 2. So we know the least common denominator of 1/12 and 5/18 is 36. So we're going to multiply 3/3 for this, multiply 2/2. Then we have a denominator of, let me write here, 36. So 1 times 3 is 3, plus 5 times 2 is 10. So combine those two, in the end we've got a 13/36. It cannot be simplified, so we just leave like that. And then this, when we break down into 3, 2, 2, 3, 2, 3, this is called a prime factorization. Prime factorization. So this process. So when we break a number down, let's say 12 equals to 2 times 2 times 3. You see, 2 is a factor, 2 is a factor, 3 is a factor. So that's why it's called a factorization. And 2 is a prime, 2 is a prime, 3 is a prime. Okay, so this is prime factorization of 12. So similarly, we're going to do the same thing for expressions, for rational expressions. Let's see this example. So in this example, we have 2 rational expressions. The first one, the numerator is a quadratic or polynomial degree 2. The denominator is also polynomial degree 2. And the second one is numerator is linear, polynomial degree 1. The denominator is also polynomial degree 1. So we need to find the least common denominator of those two. So what do? Basically, to find least common multiple of 10x squared and 15x, right? Now 10x squared, let's put in a factored form. That's 2 times 5 times x times x. Let me use red color for that one. And 15x can be factored as 3 times 5 times x. Now the least common multiple has to include all the factors in both, right? So first we have first we just write down everything for 10x squared. So 2, 5, or maybe we do a number first. Right, we have 2, we have 5, or 5 is here. We only have to write it once because 5 is a common factor of those two. But then we have this 3, so we need to multiply by this 3. X is a common factor, we only write it once. But then we still have this x, so we need to write down this x. Then 2 times 5, 10, 10 times 3, 30. X times x, x squared. So the least common denominator of those two is 30x squared. So if we want to change the first one to be 30x squared, we only have to multiply by 3 over 3, right? And second one, we need to change 15x to 30x squared. We need to multiply by 2x over 2x. When the numerator is a binomial or trinomial, more than one term. If it's a monomial, we don't need to put a parenthesis. Otherwise, we need to put a parenthesis because this 2x will multiply by x or multiply by 7. Similarly, this 3 will multiply by 3x squared. This 3 will multiply by 7x. Okay. So the least common denominator of those two is 30x squared. Now let's see example 2. So the first one, we have the denominator will have 2 factors. We have 7x and x plus 2. And the second one, we have 3 times x plus 4 squared, right? So let's figure out. So we need to find the least common multiple of 7x, x plus 4, and 3 times x plus 4 squared. So 7x times x plus 4 is obvious. So we have 7 as a factor, x as a factor, x plus 4 as a factor. So we write down everything. We write down 7, we write down x, we write down x plus 4. So the second one, we don't have 7, but we have 3. So we need to write down 3 multiplied by 3. We like numbers multiplied by numbers. So we write multiply by 3 with 7. Then x plus 4 squared. Well, what's x plus 4 squared? That's x plus 4 times x plus 4. 1x plus 4 is already here, right? It's common factor. But then we have this x plus 4. So we need to multiply by another x plus 4. Or we just write it as 3 times 7, 21. x times x plus 4 squared. So this is the least common denominator of those two rational fractions. Then if we want to change this one to have a common denominator, we need to multiply by 3. We need to multiply by x plus 4. Then we give parentheses of this one. Same thing for the denominator, because for expressions, we can only multiply by 1. 1 is any expression divides itself. And for the second one, how do we change 3x plus 4 squared to 21x, x plus 4? We need to multiply by 7x over 7x. And give a parenthesis to this trinomial. Okay. So least common denominator is 21x, x plus 4 squared. Very tricky how to move this screen. Okay, let's see. This is 3 exercise. So the first one we have 7 divided by 15x squared. Second one 9 over 24x. So basically we need to find the least common multiple of 15x squared and 24x, or least common denominator of those two rational expressions. So 15x squared is 3 times 5 times x. And 24x is 3 times 6 times x. Well, let's look for all the factors. So the least common multiple has to include all the factors. So first we have a common factor 3. Then we have this 5. Then we have this 6. Then we have this common factor of x. Then we have this x. So 5 times 6, 30. 30 times 3, 90. So 90, x times x squared. To change the first one to have 90x squared, so we need to multiply by 6, right? 6 over 6, basically. Because 6 times 15 is 90, 90x squared. And the second one, how do we change 24x to be 90x squared? We need to multiply by, oh, I did something wrong. Sorry. I did something wrong. 24 is 4 times 6, not 3 times 6. Okay, let's erase this. Let's erase this. This is not. Also need to erase this one. Let's redo this too. Right, 24 is 4 times 6. Or 6, so 6 is 3 times 2. So let's have 3 times, or even 3 times 8. Let's do this one. So 24 is 3 times 8 times x, right? So we need to include in 3. 3 is here. Then we need to include in 5. We need to include in 8. Then x. So now 5 times 8, 40. 40 times 3, 120. So it's 120x squared. So change this one, 15x squared to be 120. We need to multiply by 8 divided by 8. Change 24x to be 120x squared. We need to multiply by 5, right? 5x over 5x. Please look at this. So 24x, you see 3 times a is 24, then pick 1x, so what's left? 5x. So that means we need to multiply by 5x over 5x. Now let's see the second one. Second one, the first one has one factor, x plus 3. The second one has x plus 3 and x minus 3. So obviously, the least common denominator is x plus 3 times x minus 3. So this one, we don't have to do anything. Just the first one, we want to multiply x minus 3 over x minus 3, right? Just like if we have half plus 1/8. You see, we don't have to do anything, 8, right? So least common denominator is just 8. So we just multiply 4 over 4. So same idea. The least common denominator is x plus 3 times x minus 3. It's this one. This one is the least common denominator. So we just multiply the first one with x minus 3, divides itself. Now let's see 3. 3x squared minus 4 is a difference of 2 squares, right? That can be factored as x plus 2 times x minus 2. Then the second one has x times x plus 2. So the least common denominator should be x, this factor, times x plus 2, this common factor, then x minus 2. So change this one to have a common denominator, we need to multiply by x minus 2, divide itself. And change this one to have a common denominator, we need to multiply by x over x. X squared minus 4 is x plus 2 times x minus 2. Okay, let's see this one. Last one, 4. We only focus on the denominator, okay? We don't pay much attention to the numerator. So let's compare those two. Let's write on the side. X squared minus 25. That's difference of 2 squares. Right, that's x squared minus 5 squared. That can be factored as x plus 5 times x minus 5. And x squared minus 10x plus 25 is a perfect square. Because 25 is a 5 squared. Because I claim this is x minus 5 squared, which means x minus 5 times x minus 5. But usually don't write that way. We write it in the shorthand notation, x minus 5 squared. Remember, perfect square is the first one squared. First one is x squared. And second one squared, negative 5 squared, 25. Then 2 times the first one times the second one. 2 times x, then multiply by negative 5. Indeed, that's negative 10x. Okay, so what is the least common denominator? I have x plus 5, x minus 5 once. Here I have x minus 5 twice. So the least common denominator is x plus 5 as a factor, x minus 5, 2 of them, squared. So the first one, I just need to multiply by another x minus 5 divides itself. And this one, I need to multiply by x plus 5 divides itself. When I multiply, I need to give parentheses to others, x plus 5. Okay, I think that's it. Yeah, that's today's notes.